All right, as I'm making the answer key, I thought I'd just make a video. If you want to see it, this is for you. So here we go. One-liner. We're gonna just apply, in this case, this is as simple as it gets. So if you look at all the steps here, right, we just essentially just stick with this, okay? And I look at there are no exponents affecting the individual brackets, so it's just cross multiplying, like multiply right across, right? So 7 times 8 is 56, m squared and m cubed is 5. You add the exponents, n cubed and n squared is also 5, k and k cubed, that's k to the 4, right? That's it. So equal sign that right next to it. So that's all that is to it there. For B here, again, I'm looking for, are there any individual exponents? No, so I can just cross multiply. So 3 times negative 5, that's negative 15, times 2 is negative 30. Watch the negative. P, another P, so that'd be P 1 plus 1, that's 2, right? Q, there's a Q squared here, and there's a Q cubed, that's 5 Q's then. R, there's 1, 2, and another 2, that's 4. Okay, so there it is. That would be the answer to B. And then C, there it's a little tougher because you're seeing that this exponent is only applying to this expression here, not these other two. So let's go ahead and do that first. So remember, it will multiply the exponent of whatever is inside. You have to make note that there's a negative 1 here. Okay, so I'm going to actually go ahead and just say you cube any number that appears, just apply the power that's outside to it. All right, that's basically it. And then it's r1 times 3, which is 3. S to the 1 times 3 is also just 3. T squared times 3 is 6. And this, so this whole expression turns into this. And I'm going to close that here. We can already apply the 2 times this, right? So that'd be 12s4 t5. And my next step, so equal sign, right? Equal. And so this turns into just negative because any negative value to the power, to an odd power will be negative, right? So that's just negative r cubed s cubed t6, sorry. And this is 12s4. I should do my s like this, right? S4 t5. And so that is negative 1 times 12 is negative 12. R cubed, there's no other r, so that stays s cubed, and s to the 4, that's s to the 7, like this, right? Should make my s's like that. S to the 7, t to the 6 and 5 is 11. So that's your final expression. Oh, you can't see that there. That's your final expression for C. Right, and then D, I will fold this up so that we can continue just from there, like so. Okay, so for D, I have exponent to this and an exponent to that. I will do that first, okay? And so negative 4 squared, right? You'll square the whole negative 4, so that's positive 16. 8 to the 8b squared. Close that bracket. Nothing happens there. So I'm going to keep that for now. 3 cubed is 27. A to the negative 3. Watch this. A to the negative 3 and b to the negative 2. Now there, I normally tell you eliminate it, right? Get rid of it before you apply the power. Because this is a one-liner, for now, I'm gonna just keep it like that. If this had been an expression where you had like a outside exponent yet as well, I'd probably bring it down right away. Or, you know what, I'm thinking I need to be consistent as much as possible. So I'm actually gonna say 3 cubed is 27. I'm gonna bring this down. I'm gonna bring a cubed down, b squared like that. And this whole thing, I should probably leave this as a 3 so I can apply the cube to the whole thing. So I brought these two down as a positive. Now, Mr. Dirksen, what if I had just kept it like this and I went negative 3 times 3 is negative 9, negative 2 times 3 is negative 6, and just kept it like that and worried about that at the end? It would have worked. It would have worked. I would consider this almost like a numerator where you're just cleaning everything up. You're not yet worrying about bringing about this step right here, which is after, right? But I can tell you that you're gonna end up with the same final answer if you do it correctly. Okay, so here you have, I'm gonna clean this up already. 16 and 2, that's 32. A to the 8 and 5, that is 13. And then b is b to the 5, right? I can clean that up. And now I'm going to do this. That's 27. I'm applying the 3 to everything inside. That's a to the 9 and b to the 6, like this. Okay? And you might wonder what happens here, right? You can, because this is multiplying like this, you can assume that it's only when things are multiplying that this denominator is going to be the denominator for this whole thing. So you multiply across like this. 32 times 27, right? You figure that out on the side, right? So here 32, if that happens, right? Times 27 like that. 7 times 2 is 14. 7 times 3 is 21, that's 22. 2, you put a 0 down here, right? 2 times 2 is 4. 2 times 3 is 6. That's 864. Right? So that's, you get 864 on top, and then it's A13 B to the 5 over A to the 9 B to the 6. Okay, I will show you an alternative to this. And now you still have to clean it up if you're trying to simplify. So 864, A13 minus 9, B5 minus 6. That's what you get. That's 864, A, and this gives you 4. This gives you negative 1. And then you want to get rid of the negative at all costs at the end, right? So that's A to the 4 over B. And that's your final answer right there. Okay. I will give you an alternative solution to this, right? So I'll say or. Let me just do it this way. Let's say I would have cleaned this up. So it's 16 A to the 8 B squared like that. And then this, nothing happens there. And here it's 27. I just kept it like that. A to the negative 9, B to the negative 6. Let's say I just kept it. I just kept it in line like this. Sorry, I completely blocked that. But anyways, I just performed this step is the same as before, but then I applied that 3 to everything, and I just went negative 3 times 3 is negative 9, and you get negative 6, and just left it like that. Because this is not a fraction to begin with, to start off with, I would just leave it like that, perhaps, right? And then you know that 16 times 2 is 32 times 27 is 864. We already figured that out. Then it's 8. This is where I would actually show my work. 8 plus 5, right? Minus 9 because it's right subtracting there. B squared plus 3 minus 6, like that. And then this would turn out to be 864. 8 and 5 is 13. Minus 9 is 4. 2 plus 3 is 5. Minus 6 is to negative 1, right? And that gives you, now you want to get rid of the negative 8 to the 4 over b, right? So you get the same answer like that. If there had been now yet on top of that an external outside power, you'd apply that at this point. So as you can see, there's some variation allowed here as long as you're consistent, right? And so that is D. Let's continue with E. E should be pretty doable. Right? E is pretty doable. So we'll just say that it's Q to the 9 over Q squared, and that all squared as well. So you took care of the numerator. There was nothing in the denominator. No need to simplify coefficients. So we're going to collect like bases this way. So it's Q9 minus 2 squared. So that's Q7 inside, right, squared, which is Q14, right? So keep that in mind. Next page, F. Let's see if we can master that one. So this is more applicable, like those steps that I gave you. This basically has more or less everything in it. So right, like, so that is a general way of going about it. So I'm going to do my numerator first, looking for any exponents that apply specifically just to that little bracket, and nothing is there. So I can just go ahead and cross multiply. I'm going to keep the big one there, and that's negative 6 x to the 5 y to the 5 over x to the 5. Okay, all of that squared. Now, if you see this, if you see the same base with the same exponent, you can just cancel out like that, right? And that gives you negative 6 y to the 5, all of that squared. Nothing anymore in the denominator. There's a 1 there, but we can just ignore it. And that would give you positive 36 y to the, not 25, y to the 10, right? There it is. That's your answer. And G. G here. And we'll do the last two. All right. So we have this one here. Has more happening. You can see coefficients. You can see that the numerator has its own little exponent, right? So when I say numerator, look at everything that needs to be done on the numerator. Then we go to the denominator. We do everything that needs to be done there. Then we look at the coefficients. Then we're going to collect like terms going up and down, right? If there's any negative exponent after doing that, you flip it, right? You move it up and down. And then you apply the outside last. Just be careful that I see a lot of students wanting to turn this into a positive 2, so they'll bring it down. That is incorrect, okay? You cannot change the sign of anything if you bring it up and down. In fact, you can't do it. It's wrong. You can only change the sign of the exponent, not the coefficient, all right? Keep that in mind. So maybe I'll write that down here. -2, right? You cannot say that it's positive here. That is not wrong, right? You cannot do that. You can do 2 to the -1 is 1 over 2 to the 1 positive, right? That is correct. Okay, flipping, bringing it down or up only changes the exponent. And default exponent for anything that doesn't have one is 1. Okay, so there you have it. So G, I'm going to apply this power to everything up there. It's odd, so that will be so you can go 2 to the power of 3 is 8, but it will be a -8 nonetheless. And here, see how you have that negative? At this moment, you can't bring it down because it's anyway locked in with this one. So I'm going to leave it there. X to the -9, y to the 12, okay, over there's nothing happening in the denominator. You can just copy it down. All of that to the power of 5. Okay. Now I can clean up shop, right? I can clean up coefficients. 8 goes in here once, 8 goes in here twice. So you should have an equal sign here anyways, because you're doing the work right next to it or below, it doesn't matter. Because you're saying every step of the way is actually the exact same. It would give you the exact same value. If I said that, hey, evaluate this if x is equal to 2 and y is equal to -3, and you were to plug it in here and figure it all out with a calculator perhaps, and then went to the one right next to it and did it again, you should get the exact same value every step of the way. Okay, so you have negative on top, that's just 1, so we'll just do negative. And watch this, x to the -9 is already there. Okay, now you're going to go subtract 12 because x is, they both have the same base, so you go top, whatever top is, subtract bottom. And you will have instances where the bottom is negative as well. So if you go -9 minus -12, the 12 would actually turn positive. It's not the case here, but just remember it. It's coming soon to a city near you, all right? 12 minus 7 over, what do we have in the denominator? We have the 2, and that's it. All of this was taken care of, right? When you subtract, like you're left with nothing there. Unless, let's say there would have been a z here. If there had been a z here, then obviously a z is still left here, okay? So keep that in mind. All that to the power of 5. Clean that up, that's negative. This is -21. And this is 5 positive over 2. All of that still to the power of 5. Okay, and then continue here. Now I'm going to get rid of the negative exponent, right? So I'm going to go negative y to the 5 over 2 x to the 21. All of that still to the power of 5. I've taken care of everything on the inside slowly, right? Now I'm going to apply the 5 to everything. It's an odd power, so the -1 will stay negative. Y, 5 times 5, that's y to the 25. 2 to the power of 5 would be 32. X to the 21 times 5. So there you have to do some math, right? That'd be 5, sorry. 1 times 5 is 5, 2 times 5 is 10, so that's 105. right? X to the 105, and that's a negative there. And this is what your final expression should look like, okay? So that one is a bit more challenging, and I will scan this and post it anyways. Last but not least, here we go. H. So I look at the numerator, there are small exponents applied to each one of those brackets. I'll take care of that first. So that'd be 2 squared is 4m squared, n squared, right? These technically both have a 1, and you just multiply it, and you're left with that bracket. And then 3 cubed is 27. M to the 6, n to the 12, like that. You're left with negative 12 in the denominator. This is applied just to that, so it's m to the 4, n to the 20. All of that still to the power of 3. Okay? Equal sign, right? Don't forget that. And then here, now, what I did, I cleaned up the denominator. You're like, shouldn't you be doing the, you can clean them up both in one step, but right now I'm going to focus back on the numerator. So 4 times 27, that is 8 there, 28, right? 4 times 2 is 8 plus, so that's 108. And then m and m6, that's m to the 8. There you add, right? N squared and n12, that's n14 over negative 12 m4 n20. All of that still to the power of 3. There's something that I say that the negative always floats up. I like to have it in the numerator, so I'm going to do that in my next step. So continuing from here, I can see that I can fit, there are numbers that fit into both of them. Okay, so if I'm going to try two for sure, right? They're both even. I'm going to try 4. 4 goes into 4 goes in here. Actually, I want to make it easier for you. 4 goes in here twice, right? You're left with 28, that's 7. So you can actually fit 4 into both. I think what would have been easier is if you would have simplified them here already, because now both of these do not have a power anymore. It's already that's already done. So when you have numbers like this and these numbers are multiplying here and dividing, you can already simplify that before you move on to the next step. So I think I want to do that because it will give you less trouble down the road. So I cancel, I'm going to say here 4 goes in here once, 4 goes in there 3 times. And then you can cancel it even further, right? Because you can say 3 goes into here once, 3 goes in there 9 times. So really just this goes down to 1 and 1, and that is to 9. And that just means that over here, when you had 108 over 12, that means that 12 went into that as well. Okay, 12 went exactly into 108. Okay, so you're left with just 1 down here, just minus like that, and at the top you're left with 9. Just be warned, don't do it here because this is 2 squared, not just 2. So you can't cancel it out. You won't get the right answer there. Okay, so just be warned there. And so we're here. So I guess what I'm gonna say here is if you had multiplied this out and then this and then reduced it afterwards, it would have just been a bit more difficult to do. A little bit harder. You would have probably had to figure out because once you would have simplified it, let's say you would have divided them both by 4, right? Like let's say we had 108 over 12, right? Let's say we had divided them both by 4, and we figured out that 4 goes in here 3 times, 4 goes in here 27 times, right? And you're like, oh, wait a minute, I can keep going. 3 goes in here once, 3 goes in here 9 times. So you would have still arrived to this 9 over 1 over here. So most of the time the numbers won't be that big anyways, but you have to just be careful, choose which method when you want to do it. You're just gonna have to do some mental math there, right? So now we're gonna collect like terms going up and down. I'm gonna make this float up, -9, m8 minus 4, n14 minus 20. All of that to the power 3. You may ask, what happened here? I'm collecting them all up here. Okay, so there's really just a 1 down here. And so I'm going to go -9. That's m to the 4, n to the -6. All that's still cubed. And so now I'm going to get rid of the negative power. So -9 m4 n to the 6. I'm going to cube that. I got rid of the negative, brought it back down. Now I'm going to apply that. It's an odd power, so this will be negative, a negative answer for sure. 9 times 9 is 81 times another 9, right? So you got to go 81 times 9 in a sense, right? 1 times 9 is just 9. 9 times 8 is 72. So 729. So 729 m to the 12 n to the 18, and you're done. Okay, that's it. Make sure you do page 221 and the other homework questions as well if you haven't done them yet. And that's it. Enjoy.